This is the Internet Report, where we uncover what's working and what's breaking on the internet and why. This week, we're going to cover a really interesting BGP routing incident that we uncovered and took place about a month ago, but there were some really interesting things associated with this particular BGP leak. So we wanted to kind of step through what happened and also provide some analysis on what caused the incident and some takeaways in terms of what you can do to prepare for and protect yourself against these kinds of incidents. And so to unpack this, particular incident we're going to cover, I have Kemal. Kemal is joining us. Welcome, Kemal.
Thank you so much, Angelique. It's awesome to be on the Internet Report again.
Let's maybe quickly look at what happened in terms of the timeline. So we can see here that the incident started around 10:24 UTC, and then it eventually resolved around 10:48 UTC. So initially, we saw a very significant level of packet loss when trying to reach a particular service. And some of our customers noticed this when they were testing to their own service, and we noticed this more broadly, that all of a sudden traffic was getting routed to a service provider that's Russian-based, and this is EDN Sovintel, which is part of Vimpelcom, and we can see here they have AS3216, and they weren't previously in the path, but all of a sudden they were inserted into the path, and as a result of that, we see a spike in packet loss that eventually subsided. So what's interesting about this, if we go to the BGP path viz, is we can see the significant number of path changes that occurred over this period. So starting around 10:15, we can see if we just look, for example, at this particular BGP monitor, we can see that the initial path was fairly short, just a few AS hops. And then all of a sudden we see a much longer path getting installed, and this happening in rapid succession, which is really strange because it would be very unusual for a longer path to be preferenced over a shorter path. So to discuss kind of all this and what we were able to uncover as a result of looking more deeply at this, what are your thoughts on that, Kemal? Why first of all would we see this particular Russian telecom inserted into the path?
Yeah, I think that's like something that sparked our interest originally. Why would longer AS path get into the picture? And even more substantial question would be, how did that happen, given the fact that path previous to this event happening actually included some of the tier 1 providers such as Telia and NTT and stuff like that, who we know are quite well peered. So the real question is, like, why would longer path be preferred to the shorter path? It took us quite some time to actually understand what really happened, but deep dives into the routing table and particularly into the updates when this event happened tell us that it looks based on the it looks like that Vimpelcom, or Beeline, how it's also called, it's basically a large group that has between 1 and 5 terabits of traffic globally. It looks like they were doing either some maintenance or they were establishing BGP session towards Birza, or I think it's also known as Cyrex, circuit exchange. And it looks something went wrong. Now, the real question here again is what actually we think that happened. And analyzing routing tables and updates that happened approximately at 10:05 approximately to and that went to 11 p.m. indicates that it seems that Wimpelcom advertised the prefixes that they are learning from their other private peers to their newly established or maintained peer, which as a result had this effect, as part of which longer path prefixes with the longer paths got installed, which subsequently attracted a lot of traffic towards that path. So basically, Wimpelcom was serving kind of as a transiting ASN for a certain amount of time. It's quite interesting from the perspective of the fact that we saw packet loss, and packet loss could have been just purely happening just purely from the fact that they attracted quite a lot of traffic, because they propagated quite a lot of prefixes at the same time, which we're going to show a little bit later on. But in general, it comes down to the basics of BGP. When it comes to BGP, we know that we have several different types of peering. So we have private peerings, we have IX connections, or IX peering over the IX, or internet exchanges. We have paid peering, and we have transits. And basically, in the order that I just mentioned them, you tend to configure BGP policies to prefer those peerings based on these criteria. So for example, you are going to likely prefer more private peering over the paid peering over the transit. And there is a cost associated to it, and there's also a factor of performance, right? You peer with someone directly so that you have direct connectivity to that particular provider. And usually those things happen at internet exchanges as well. So that's the first part. The second part, and before I jump to the second part, it's really important to mention that the policies are configured in such a way using usually using local preference. Local preference based on the BGP best path selection algorithm is second BGP attribute that gets tribute. So the higher local preference is, the better it gets. So usually when you are receiving prefixes by your private peer, you are gonna set the local preference to be high so that you prefer it to over, for example, transit, so that you egress to those. On the other side, and this is point number 2, over these peering sessions, you usually just or mandatory pretty much, you advertise your own prefixes that you are originator for, right? So based on our analysis on this event at 10:05 on the 3rd of June, it looked like Wimpelcom was doing either some maintenance, or they were setting a new BGP session with Birza or Cyrex. And it's likely that there was a configuration mistake, as a result of which it looks like they advertised the prefixes that they are learning from other private peers, which is not what you do. So from that perspective, it's what's considered to be a leak. Now, to our big question, the answer to our big question here is, how come that prefixes with the longer path got installed? It got installed purely by the fact that the new peering partner accepted those prefixes, and because they were coming from the session that was private peer, which probably has a higher local preference than transit and other ones, it installed them in the routing table, and it re-advertised only the best prefixes, which is basically BGP default behavior. You advertise a single best prefix from your routing table to your peering provider. And then subsequently, that prefix got installed, given the fact that Cyrex is a private peer to someone, and event kind of like cascaded to the certain point down the stream, as a result of which all of a sudden some of the BGP collectors that we analyzed saw that, and that we showcased a little bit earlier on at the start of this call, they installed the same prefix that now uses the longer S path, right? So that's the explanation. Basically, it comes down to the BGP basics, the fact that BGP peers are re-advertising only the best prefixes. And then the second thing is that it seems that here the root cause is the fact that Wimpelcom advertised their partner prefixes that they are learning over the private private peering with the other companies, and then that got kind of propagated further line.
Right. So basically, they shared more than their own prefixes. They were a private peer, and so they were preferred from a routing standpoint. So it sort of overrode the lengthier paths that they were using. And so, so now those start to get propagated out. We don't know necessarily the scope of the propagation, but there were a number of different transit providers that were then using this route and sending traffic through one or multiple Russian service providers. Now, it didn't last very long, but not a lot of people noticed it. From the standpoint of a enterprise that might have a web property or their own site and want to ensure that this doesn't happen, what are some options? I mean, there's not a whole lot that you can do beyond your own service providers in terms of influencing routing, right?
Quite correct. So to your point, I think that the most important aspect of this event is lesson about network visibility, right? First of all, this was, even though some of our customers most specifically noticed the event, and there was not a lot of press about it, right? And quite significant amount of traffic went over some Russian providers
Right.
for good 20-something minutes, right?
Right. This is more than 100,000 prefixes. Some of the prefixes belonging to Google, Apple, Oracle. So, potentially some major
Financial services as well.
Yeah, we're getting, they were eventually reaching Google or wherever they were destined, but they were just getting, that traffic was getting flowed through these Russian service providers.
Exactly. So what was, so from the BGP perspective, here, what could have you done, right, in terms of this? Like, so your options in these kinds of cases are kind of limited. When it comes to transit providers, they usually offer you a certain level of control using BGP communities. So there is an RFC 1998 that actually deals exactly with this scenario, as part of which you can manipulate your traffic that you are advertising, or for the prefixes that you are advertising to your ISPs, right? But it only goes so far in terms of that you can affect potentially only the first hop after your ISP, but beyond that, it's completely outside of your control. And that's what we see here. Even though some of these companies had a really good connectivity with a quite short ISN path, so for example, we saw like 3 or 4 hops away, kind of like targets, sources or targets being away from the destination or the target, depends on how you look at it. We saw that all of a sudden, like path was kind of changed so that quite longer ASN path is in motion. And that's like basically one of these things. So when it comes to protection here, the other question beside what are the controls from the BGP perspective that you would have, there's not a lot, right? If you are advertising more specific prefix that you have, such as /24, like you are pretty much out of options, right? Your option would be to advertise more specifics if that's not the case, because more specific always wins regardless of how it goes. But then it's again very questionable of how it would propagate down on the internet. So that's the first thing, right? The second thing is RPKI, right? The question is, would it help? I don't think it would, because in this particular case, we are not dealing with the hijack. We are dealing with legitimate configuration mistake potentially, as part of which origin stayed the same. So there was never an aspect of whether someone actually started introducing something else in the path. However, what would have really worked here is very a simple method that's out there for a long time, and that's usage of maximum prefixes on the peering sessions. So even Wimpelcom or Beeline, how it's also called, on their peering database profile page indicates that prefix list or maximum prefixes on their peering should be set to 20,000. They have approximately 25,000 prefixes that they are advertising, and they are suggesting that. When the event happened, we saw that there is approximately at 10:05 on UTC, there was around 100,000 updates, or technically speaking, there was 100,000 prefixes that had Wimpelcom and Internet Exchange ASN in the pot, right? So which potentially meant that they advertised quite large space. And if there was maximum prefixes configured from their peering partner side, that BGP session would be dropped, and this wouldn't have happened. But that wasn't the case. But their peering provider is not only a company at stake here. Their peering partners as well accepted those updates. So basically, it kind of propagated to the fact that to what I would say missing of BGP fundamentals, such as implementing some sort of protection. We know that BGP doesn't have a lot of protection, but what it does should be used.
Well, it looks like they've implemented a filter post-event, because they currently have a prefix filter of what, 20,000 or so?
25. Basically they are saying that prefix maximum prefixes on their peering partners should be set to 20,000.
Right.
So, right. Which goes to say that we obviously don't know whether that was the case or not, but it looks like they for sure advertised at 10:05. They advertised 100. Following that, there was at 10:10 there was additional 30,000 and 40,000 5 minutes after that. Prefixes advertised that had these two ISPs in the pot. So now, while we see updates coming with these ASNs in the pot, we don't know how many of routers down the path on the internet accepted those, but we know that, as we said earlier, certain financial companies got affected. Also, some of the FANG companies, such as I think I saw Google, large companies such as Oracle is there as well, and most certainly other financial customers that had their traffic rerouted as a result of this event.
Right. So max preference filter would really only work if you're the service provider. Obviously it's good to have good hygiene, BGP hygiene, but what about for an enterprise? Is there anything that they can do or should have in place in order to, at least be aware of when these incidents are occurring?
So from the perspective of everyone, maximum prefixes should be used, right? One of the things that when you are negotiating the peering with your peering partner, you should ask about what is the approximate or most definitive number of prefixes that you're going to be advertising. And based on that information, you should configure max prefixes on BGP sessions. Regardless whether you're enterprise, large-scale ISP, doesn't really matter, right? That should be by default there. I think that's one of the things in general that Manners is suggesting as well. But I think back to where we started this conversation is that the big thing that a lot of companies, enterprises, and large-scale companies seems to have missed is that this crucial visibility into that this kind of thing happened, right? And the thing is, this is gonna keep on happening as well. The question is, what can you do? You can utilize protections that are already there, and then the other thing is you can potentially react in different ways once it happens. But in order to do so, you need to know that actually event happened in the first place.
Right, right. So you definitely need visibility, and getting alerted on BGP changes is important. You know, if you see, for example, that a particular AS that you don't necessarily want to be in the path to your service, you know, if you can, well, with ThousandEyes, of course, you can set up alerts to do that and get notified of those type of important changes. So, you know, always good, of course, you know, out on the internet to make sure that you have good line of sight to everywhere you want to go, and you know, from everywhere your customers are to your site or application. So, yeah, lots of really interesting stuff to take away from this event. So with that, we'll go ahead and close out the show this week. Thanks very much, Kemal, for joining us. And until next time, take care.
Thank you.